today we're going to talk about how to find or how to calculate the distance between 2 points on a coordinate plane using the Pythagorean theorem. And we're going to do this by using the distance formula. So let's back up. If I were to plot these 2 points, so on an x and y coordinate plane, I'd get 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's 1 point. Here's 3, negative 9. My second point, negative 9, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 7. 1, 2, 3, 4, 5, 6, 7. Here's my second point. There's no way that I can find the distance from this point to this point diagonally by counting any shapes or any spaces. I could do that if I was moving up or down the y-axis. I could do that if I was moving side to side on the x-axis. But because this is diagonal, I can't do that. So what we do is we find where they meet, where they would form a triangle. So here's one leg. Here's the other leg to find the hypotenuse. Does anyone remember the formula for the Pythagorean theorem? What is it?
A squared plus B squared equals C squared.
Good. A squared plus B squared equals C squared. So in this case, for right now, we're just going to count the spaces. The distance between negative 9, 7 to negative 9, negative 9. So we're counting the spaces. We're going to say it's from here to the 0, we've got how many spaces in between? Because we're traveling on the y-axis. Therefore, 7 to 0 is 7. Now we're going to travel from the 0 to the negative 9. How many spaces? How many? 9. So it's positive 9 because we're moving, right? Now we add it all together because that's the total of the leg. 7 plus 9 is? 16. So our first leg, if this was a triangle, a right triangle, or we have to find C, our first leg would be 16 spaces or units apart. Now we're going to do the same thing over here. We're traveling on the x-axis, so from the negative 9 to 0, we move how many spaces? 9. From the 0 to the 3 on the x-axis, how many spaces do we have? 3. So now we add them together. 9 plus 3 is? 12. So my second leg, which we can call B, measures 12. Now can I find the hypotenuse, the distance away that negative 7 is away from 3 and negative 9? Can we? No? Yes? Maybe so?
Yes.
We have to use like
Yes. Okay, so what would we do, William? What do we do?
A squared.
16 on one leg, 12 on the other. We have to find C. C is the longest leg. It's the hypotenuse. What is it?
Use the formula A squared plus B squared
Equals C squared. Good. So I'm going to plug in. A is what? 16 squared plus 12 squared equals
C squared.
C squared. So now I have my formula to find the hypotenuse. Does anyone know what 16 squared is? Josh?
256.
256. Good for knowing your perfect squares. What's 12 squared?
144.
We all know that one. Good. And all of that combined, the sum of those two will be C squared. 256 plus 144 is 400. Equals C squared. And this is another perfect square because when we find the square root, C equals what?
20.
20. So now I know that the distance between negative 7 and 3, comma, negative 9 is 20 units apart because I found the hypotenuse. Well, that's a lot of work, right? And we're not always going to have the opportunity to draw a coordinate plane out for every single one of our points. So we can use a a formula, and this is what we call the distance formula. Can I erase this?
Yes.
Yes, no?
Yes.
Okay, thank you.
We have to.
So so I'm gonna erase this. We're gonna use something, it's gonna give us the same answer. I'm actually gonna move it to the side. I'm gonna keep the Pythagorean theorem, but this I'm gonna say c squared equals a squared plus b squared. Okay, the distance formula. Is d, which is the distance, but between 2 points, that long distance when it's diagonal is also the what? The hypotenuse, the longest leg on a right triangle. Yeah, so the distance between point A and point B, that's D, but it's also C. It represents C. The square root of x2 minus x1 squared plus y2 minus y1 squared. Good. It looks very similar to this because I could rewrite this to say c equals the square root of a squared plus b squared, where c is d, x2 minus x1 is a, y2 minus y1 is b. Just like we did in the beginning where we found the spaces between one leg and the other. So the exact same formula, you just have a few more numbers to deal with. Go ahead and write it down in your notes. So d equals, the distance formula, d equals square root x2 minus x1, parentheses squared, plus y2 minus y1, parentheses, remember, those are important, squared. So now I'm gonna plug it in. So you know that when I plug in numbers, I keep everything the same. So I'm gonna say d equals the distance, the square root of, well, x2 and x1. Whenever I'm looking at points, I immediately label them. x1, y1, x2, y2. Just so we don't get confused because there's a lot of numbers involved. So what's x2 up here? What is it?
-9.
Thank you. -9. Minus, here, I'm actually doing a different color so you can see it better. -9 minus, what's x1? 3. Good, and it's all squared. I'm gonna keep that parentheses. Now my second one. What's y2? 7. What's y1? -9. But don't forget that we need to have that subtraction ready. -9. And it's all squared. Yeah, so now we solve what's inside the parentheses. -9 minus 3. Well, we add the inverse, the additive inverse. So the additive inverse of -3 would be +3. Sorry. The additive inverse of +3 would be -3. So I'm adding -3. -9 plus -3 is -12. And it's still inside the parentheses. Because if we remember the rules of exponents, x when it only applies, the power only applies to the number directly next to it. In this case, it includes the negative. Plus 7, okay, again, we're gonna add its inverse. Add the additive inverse of -9, it's +9. 7 plus 9 is 16 squared, and it's all square rooted. -12 times -12 is positive 144 plus 256 because we're really excited to know our perfect squares.
Yes.
144 plus 256 is 400. Square root, it's also a perfect square. Therefore, distance equals 20, which was the exact same number we got when we had to plot it, count it, then apply those numbers of the legs into the Pythagorean theorem. It's the exact same thing. you just have something to follow, like a blueprint to follow. So please make sure you're writing this down if you haven't done so already. It will be on the test. Not that it matters, you should know it anyway, but it will be on the test.
I love tests.
Okay, so now I'm gonna give you two coordinate points, and I want you to apply the distance formula to find the answer. And you're not always gonna have perfect squares. So what are two ways you can, let's say it's not a perfect square. What can you do, Victoria?
Do the decimal or just leave it as it is?
Yeah, you can leave it as is. If you can't simplify, you can always simplify by finding perfect squares, or you can just use it as an estimate of a decimal. Joey?
You can do the square root, not like square root, but square root the two numbers that make it.
Yeah, we could. So we find the perfect squares, take it, and then just leave what's on the inside. Good. So let me give you a problem. And I'm just gonna put it on the side in case you're not done writing it down. Fine. 5, 9, and -7. Go ahead and try it. And then I'm actually gonna have one of you come up and try it on the board. Do you wanna do it? You got too excited.
If I finish.
you can actually come up here and do it.
Hold on, let me get the
No, black or blue.
Let me start.
Okay. Hmm? Okay, before Victoria comes up here, let's start some of it. Always begin by labeling it. It takes you a couple seconds and it'll save you a headache at the end. So I'm gonna begin with what I know doesn't change. Just so my life is easier. What's x2? Lisa Molly?
-7.
-7. What's x1?
5.
5. Sophia R, what's y2?
-7.
What is y1?
Excellent.
9. Good. So now we can solve. We add the inverse. So if I'm adding the inverse of +5, what's the additive inverse of +5? It'd be -5. Good. We'll do the same thing over here. I'm adding the additive inverse of +9. Adding, what's the opposite of +9? -9. So now I can solve. Victoria, do you want to do the rest of it? Yeah? Here. Go for it.
Okay.
So now you just have to add. Your distance between these 2 points as well would have been 20. Then you want to get a different answer. And it's okay. We can figure out where we went wrong if we did it. No, yes, maybe so. Okay, cool. I'm gonna give you a few other problems that I'll push out to your Google Classroom, and then you just have to show your work. A lot of this is practice. There's gonna be ones where you have to plot them, so you can see the connection on why we use the Pythagorean theorem to find a distance. And then there's gonna be just points, so you don't have to plot, you just apply them to the distance formula. Cool. Go ahead and take a stretch break.
Yeah.
Yeah.
Yay.